right, lesson 3 on rates. And let's start with a working definition. One type of measure compared to another type of measure. Now we're not talking always about measuring with metric. It could be money, measurement of money or time. And the book has a slightly different, so you might want to read that also. Now, I'm going to be going through this video a little bit more quickly because it was 22 minutes. I'm going to try to shrink it down a little bit. So you see there's a whole bunch of different words that we use and they're all related. So let's review and try to get write down a few things here that will help you remember. So for ratios, let's write down some words that you can use to see if it's a ratio. So if you say helps to be in writing mode, for every blank, we'll fill that in later, there are blank. All right, so let's go back to that little project on age. As you saw, the joke was people don't age at different rates. We can't say it's a 1 to 2. For every 1 year I age, you will age too, or vice versa. It's always 1 to 1. I gain a year, you gain a year. So we can say the rate of human aging is 1 to 1. For every year I age, you age a year. If I'm mixing Windex concentrate to clean my windows, I can say, for every 1 cup of Windex, I have to add 4 cups of water. All right, let's go on to rate. We just talked about that. We're dealing with measurements and comparing them. Unit rate is the same thing, except it's always referring to a rate that has the number 1 in it. Unit means 1. So whenever I say price per pound, it means price per 1 pound. And we'll get into that. So unit rate, make sure you circle that word unit so you know that it's a rate that always has a 1 in it. Proportions. Think about when you are putting a picture in a Word document. And you put that little picture in, and it has these little placeholders in the corners. And sometimes it also has it in the middle here. Now you know that if I grab a hold of one of these corners and I want to make that picture bigger, it'll make both the width and the length bigger. But if I grab here on the edge and I pulled it straight out, especially if it was a picture of a person, they would end up looking pretty fat. So that would not be proportional. So proportions means the relationships in that ratio of length to width or whatever it is increases at the same rate each time. So whatever one does, the other one does. And then up there in the corner you see scale. That is not in your math book, but it is a type of a ratio, and we're going to handle it mathematically the same way. So even though we're not testing you on scale in your math book, we're going to be doing it in science, and it is handled in the same format. So scale on a map usually is the one that we're referring to, but there are other kinds of scales. Okay, let's move on. All right, so here's unit rate. We had said unit has to have a 1 in it. And so let's just take some really easy numbers to start with. And let's say I have pounds here and dollars here. And I'm going to buy 2 pounds of apples, and it's going to cost me $4. Told you the math was easy. Unit rate means I want to know what 1 pound costs. Now, I could ask what $1 how much weight I can get for $1. But usually that's not what we're curious about. We want to know, so what is it going to cost per pound? And then I could go the other direction. I could say, well, what if I had 3 pounds, etc. And of course, this is now in a table, which is predictable. I can also do the same thing on a number line. In your book, it draws 2 lines, calls it a double number line, but really the idea is that you put one type of number on the top and one type of number on the bottom. So it's the same thing. We could say 1 pound is $2, 2 pounds, $4, 3 pounds, $6, 4 pounds, $8, etc. So these are just ways of finding unit rates. Now, we're going to be using this for every lesson in this chapter. We're going to set it up, and you've seen this before, but only as a demonstration. Now I'm teaching you how to do this. So a unit rate is where I take a number that has meaning and another number with a different meaning. And I ask myself, what if I reduce this so that one of the values becomes 1? Do you notice how I set that up into 2 fractions with one number missing? On top, I have pounds. On the bottom, I have dollars. Could have done it the opposite way. This is where I want to cross multiply and divide. I multiply this way, and then I divide by whatever's left over. So it's 4 times 1 divided by 2. Pretty easy math. It equals 2. But that's very handy when you have a bit harder math. All right, let's move on. Okay, the next thing we're going to look at is our rates equivalent. So this time we're going to look at running a lap around a track and time. So is 24 laps in 6 minutes the same as 36 laps in 8 minutes? So we're going to set it up just like we did before, but this time we don't have a missing number. We just don't know if they're equal. So let's go ahead, we'll put laps on top and we'll put time on the bottom, or vice versa, whichever way you like. So this would be 24, this would be 6, this would be 36, and this would be 8. Now remember we said cross multiply and divide. Well, we don't need to divide because we don't have a missing number, but we can cross multiply. So we're going to multiply this way, and tomorrow you can tell me, does 24 times 8 does it equal 6 times 36? I'll let you figure that out. They may be equal, they may not be. All right, let's look at the next thing. And our very last slide, this is not in the book, but we're doing it in science. We're going to give an example of, let's say that I have, on my map, I've got 1 centimeter. And I've said that my 1 centimeter is going to be an equivalent of 5 kilometers. And this, I'm going to label this as my scale. 1 to 5. Now, I want to know what that is in reality. So in reality, what if I were trying to find the distance from one city to another? Maybe it's 350 kilometers from one city to another. So what would that be if I had to draw it on a map? So there again is my missing value. And this is where I would cross multiply 1 times 350. And then I divide by the missing, or not the missing number, divide by the third number that's there to find the missing number. All right, so that's exactly the same thing, but in this case, I'm using it for changing scale on a map. All right, I think we're done. That was kind of a long lesson, but that should be enough for practicing for a couple days.